All right, we are live. This is going to be our answer key for combining radicals. We'll jump right in with number 2 here. My goal here is to remove from the radicand any perfect squares or pairs of variables. Because it's a square root, the variables are going to jump out in groups of 2. So for number 2 here, I'm going to use my jailbreak metaphor. That requires me to do the prime factorization of 108. I can split that into a 54 and a 2. 2 is prime, so that branch is done. 54 can be split into a 9 and a 6. 6 can be split into a 3 and a 2. And 9 can be split into a 3 and a 2. Or a 3 and a 3. So when I rewrite this, 2 times 2 times 3 3s. Then I'm going to write out all those r's. 2, 3, 4. Now when they break out of jail, they have to break out in pairs. And then one of the copies gets captured and disappears. So a pair of 2s can break out, a pair of 3s can break out, an r can break out, and another r can break out. So now we've got a 2, a 3, an r, and an r. And what got left behind was just a 3. Group these back together, we've got 6r squared root 3. And we're done with number 2. For number 3 here, I'll just use what I consider to be a faster method, which is try and figure out what is the biggest perfect square that fits into the numerical part of this, and then just factor that number into that. So let me just start testing perfect squares. And we'll start, I'm going to make a guess here that maybe 36 fits in. 28 divided by 36, 3.5. Maybe 49 fits in. No, not quite. So we're going to have to come down. Maybe 16 fits in evenly. And it does. And we get an 8. Well, 8 still has a 4 that can fit into it. So what is 16 times 4? 64. So there's actually a bigger square that fits in. 128 divided by 64 is 2. So if I split the 128 into 64 times 2, that is the biggest perfect square. And that's going to be the fastest method. So now let me use the product property to distribute the square root, make it the square root of 64 times the square root of 2 times the square root of x squared. Square root of 64, that's just 8 root 2, and then this square negates the square root, and we're left with just an x. That final answer of 8x root 2. All right, let's skip down a few. Number 7 looks kind of tricky. I'm going to multiply the -5 and the 5. Well, I'm just going to rearrange to start. So since everything's being multiplied here, I can use the commutative property of multiplication to rearrange this. Get -5 times 5. I'm going to bring those to the front. I'm going to bring these radicals together. Everything's still being multiplied. I can fill in these hidden multiplications if I want. -5 times 5, that's going to be -25. Square root of 20 times the square root of 20 is going to become the square root, 1 big square root of 20 times 20. That's the product property in reverse there. And so then now we've got -25 times the square root of 400, which equals -25 times 20. -25 times 20 is -500. Let's see, number 9 looks maybe kind of tricky. Rearrange this. I'm going to bring a -1 in front. Let's bring that in front. root 3, root 12. I know I can simplify that. Well, actually, this is going to be the best way. 3 times 12 then becomes 36. We all know the square root of 36 is 6. This becomes negative 1 times 6. It's just negative 6. So number 9 is negative 6. Let's just see that we got that right. Yep, negative 6. All right. Onto the back side here. We'll try to find a couple tricky ones. I guess number 12 looks kind of tricky. What I'm going to do for this one, I'm going to split that 54 into 9 times 6. So I've got the square root of 9. It's the square root of 6. And I'm going to split this 27 into square root of 9 times the square root of 3. Negative 3 square root 6 minus 3 root 3 plus 2 times 3 root 3. After I simplify my radicals, now I've got negative 3 root 6 minus 3 root 3 plus 6 root 3. Now these two cannot be combined here. They do not have the same radical, and they're not going to simplify to the point where they do. These two do have the same radical, so we're going to simplify them. Then after we do that, after we combine these, we're just going to call that our final answer. So now I've got negative 3 root 6 plus 3 root 3. Number 12. Negative 3 root 6 plus 3 root 3. All right, moving on. 14. Negative square root of 18 minus square root of 18. Right off the bat, I'm just going to make that a negative 2 root 18 plus 2 root 8. These both have square factors, so they can be simplified a little further. Negative 2 is the square root of 9 times the square root of 2 plus 2 times the square root of 4 times the square root of 2. 4 and 2 make 8. 2 and 9 make 18. This becomes negative 2 times 3 root 2 plus 2 times 2 root 2. This becomes negative 6 root 2 plus 4 root 2, which all combines to be negative 2 root 2. For 14, negative 2 root 2. Yep. All right, let's try one of these here. Slightly more tricky with the cubed roots. This one's got the slightly bigger number. We'll deal with that. So I've got 2 cubed root 3 minus 2 cubed root 2. Those can't be combined because we're not taking the cubed root of the same number. Plus 2 cubed root of 81. Is 81 a perfect cube? No, it's not. Let's see. We got to think of our perfect cubes. 2 cubed is 8. 8 does not fit into 81. 3 cubed is 27. 27 does fit into 81. So I'm going to split that 81 into a 27 times a 3. And then cubed root of 27 is 3. So this becomes 2 times 3 times the cubed root of 3, or 6 cube root 3. Now that can be combined with that for a final answer of 8 cubed root 3 minus 2 cubed root 2. So I simplified that last term. it had the same radicand as the first term, so we were able to combine them, just like combining like terms. And we get this expression here. For 18, I'm asking for this to be in your own words. I gave you a pretty succinct definition, but now I want you to change it into your own words. Check out the PowerPoint if you want that definition again. I think this will be good for this homework. Hopefully this helps you. I'll talk to you.